Hello, good morning everyone. Myself Himank Garg from EPS third year from IIT Roorkee. Today we will discussing about study characteristics of LVDT, a linear variable differential transformer. So what is LVDT? LVDT is a sensor which is used in wide range of industrial applications and to accurately measure a linear displacement. It operates on a principle of electromagnetic induction and providing a precise and reliable output signal proportional to the position of movable core. So now the principle of LVDT operations. So basically there are three principles on which LVDT work. First is primary winding, second is movable core, and third is secondary winding. In primary winding, an AC voltage applied to a primary winding and creating a magnetic field. Then a movable core is there. The position of movable core within the LVDT determine the voltage induced in secondary winding. And in secondary winding, the induced voltage into secondary windings are differently combined and provide the output signal. So after that, to study the characteristic of LVDT, we need apparatus. So this is so apparatus required to study LVDT experiment is first one is main unit. In the main unit, you can see there is electronic circuit, and then that accounts with a demodulated carrier, and there is a display where we can see a demodulated output. In here, you can see a socket which is a carrier socket, and you can connect this with the CRO, and you can see the modulated output from this. And this is a CRO which is connected with carrier excitation, and after connected with carrier excitation, you can see the modulated output in a wave. You can see the modulated output, and you can see a waveform of yes. So now after that, this is the mechanical unit which consists of a slider, and in slider you can see when you slide it up, there the movement of core will take place, and due to the movement of core, there is change in voltage in secondary windings, and we can calibrate linear displacement with change with voltage, change in voltage. And then after that, this is the whole setup you can see, and this is the mechanical unit, this is main unit, this is CRO. We connected CRO with excitation so that we can see a demodulated output, and this is demodulated output. And here you can see slide, we slide the core left and right, and see the voltage output, and we can calibrate it so that we can get to know about displacement and calibrate it with voltage. So now after that, understanding construction of transformer. So there are components. So there are the three coils. One is primary coil, and two secondary coil are there, and one movable core is there. And what happens is that when we provide input excitation to a primary coil, due to mutual inductance in secondary coil, a current is generated, and due to which there is voltage across between the two coils V1 and V2, and they are in phase of pi radian. And at a balanced condition, when V1 and V2 both are equal, they will cancel out each other, but there are some voltage left that is called as residual voltage. What is residual voltage? In instance of magnetic field or in balance at zero displacement, a residual voltage is generated. Means some voltage is there at a balance condition, that is known as a residual voltage. So after that, the principle behind an operation and working of LVDT is, as a primary is connected to an AC source, so alternating current and voltage is produced in secondary of LVDT, and the output of S1 is E1 and secondary S2 is E2. So E1 output is there and E2 is there, and I told that there is a pi radian change, phase change. So E out is total equals to E1 minus E2. So due to this, we have three cases is there when core is moved. When the core is at null position, means there is no displacement in core. When the core is at null position, the flux linking with both secondary winding is equal. So induced EMF is equal in both the windings. So for no displacement value, E out is 0, E1 minus E2 both. So it's that no displacement takes place. But it can happen that there is some residual voltage is there. And in case 2, when core is moved at upward position, upward of a null position for a displacement to upward of a reference point, in this case the flux linking with S1 is more compared to the flux linking with S2. Due to this, E1 will be more as that of E2, and due to this voltage E out is positive. So when it is upper movement is there, E out will be positive because of E1 has more voltage as compared to E2. In case 3, when core is moved to downward of null position, uh, in that case E2 will be more of that of E1. Due to this, E out will be negative and shows the output toward downward direction of reference loop. So when the movement is downward in the reference of null point, so there is E2 is more there, so we get negative voltage. So from this we can calculate E out, and the this so yeah. So now procedure to do this experiment. First we do with AC output. So what we do, we connect a mechanical unit and CRO to supply and start from zero, and we slide a core on either side and take a reading from CRO. After taking the reading, we plot a output voltage versus displacement curve, and similar procedure we need to follow for with demodulated. We need to repeat the same process, and we move a core from either to side of zero and then take a readings, and then we again need to plot output voltage versus displacement, and we can see a linearity after plotting the plot between output voltage and displacement. So now this is the observation table we get after performing this experiment. You can see we go from -6 to 6, and we take at every 0.5 centimeter distance, take a reading for demodulated output and modulated output both. So after that we can see how to perform this experiment through video.
So now we are performing Lvdt readings. So now how we can take this? So you can see on scale, this is showing 0 reading. You can see the corresponding voltage on that, and from of corresponding voltage you can see readings on CRO, a corresponding wave to that. So now how we can take readings? What we are doing, we take on both scales plus and minus, and we are taking a distance of 0.5. So now I am increasing distance of 0.5. Yeah. So at 0.5, now it is at 0.5, you can see it. So at 0.5 my readings is 3.5 and corresponding waves on a CR. Similarly what I do, I will take at minus 0.5. So when I take at minus 0.5, so when I take at minus 0.5, you can see the corresponding voltage and readings on CRO. So Lvdt scale is vary from -6 to 6, and on that scale we are taking readings. After taking readings, we plot a graph, so we get this graph.
So after taking readings, we plot demodulated characteristics and modulated characteristics, and we can see in demodulated characteristics from range about like -5 to 5, we can see a linear response. As we said, the response is for some range. It depends on properties of core. So in this experiment we get a linear from -5 to 5, and similarly here you can see in modulated characteristics we get a linear response, pretty good relay response. At 0 voltage there is some voltage is there, so that voltage is a residual voltage. So this is all about LVDT experiment. Thank you.